Algebra 3! Welcome back from spring break 2020. I know it's been a very bizarre 3 week spring break. um, we're not in the building right now, which I think, ironically, many of you would rather be in the building than doing things online. But being able to get through this NTI, non-traditional instruction, for the next 6, 7 weeks, so that we can still have graduation and then get on with the rest of your lives, is a good thing. It's a good thing that we can do this online, um, and it's sad that we're not in the building like you'd rather be for the remainder of your senior year. But what we're gonna do is basically continue and even start over this unit on rational expressions, rational functions. And we started this weeks ago, before all the craziness went down, and we were simplifying rational expressions. And simplifying fractions is something that we've actually done a couple of times throughout the year. We started this way long time ago in the beginning of the year, um, just dealing with GCF, right? Greatest common factors or greatest common factor. Um, and taking a simple example like, you know, 20 over 30. And we would look at the numbers and think about their factors, and we'd create a factor tree and break the factors down into their prime factors, right? So like 20 is 2 times 10, which is 2 times 5, and 30 is 3 times 10, which is 2 times 5. And I know I may be rushing here, but um, this example being just numbers hopefully is not too much to bite off at the beginning on our first problem back. And then you're looking for the common factors in the numerator and the denominator that reduce to 1, right? So 2 divided by 2 makes a big old fat 1, and 5 divided by 5 makes a 1. And you've heard math teachers for years say, oh, they cancel out, right? And so those numbers reduce or cancel out of the problem, and you see the remaining factors that we have, 2/3 is the simplified version of 20 over 30. And that's a great example because you just know you can cancel the zeros and you're done, right? It's 2 over 3. Move on. Why are you taking so long, right? But it all goes back to the greatest common factors, looking at factors that the numerator and the denominator have in common, and then knocking them out, right? Reducing out the factors that they have that are the same. So before spring break, we had examples like this one, where variables all of a sudden got involved. And with variables, there's definitely an element of abstraction and just confusion because the letters make things more complicated. But the issues are still the same. You're looking for the greatest common factors. And so when you have like a negative 6 into the fourth in the numerator, that literally means you have like a negative 1, right? Times 6 times n and n and n, and there's like 4 of them because that's what n to the fourth means. And the denominator is almost the exact same thing, except there are 3 n's. But at this point, the game is played the same as it was in example 1. You look for the common factors to reduce out of the problem, right? To cancel. So what gets knocked out here is the 6's. And notice I didn't factor them into 2 times 3. You can leave them as common factors of 6 and cancel them out. And then n cancels and an n cancels and an n cancels. And then noticing what's left over, what is the only things remaining, the only factors that don't reduce out of the problem, are the negative 1, right? And the negative 1 is times the n. And in the denominator, there is technically a factor of 1 left over, right? There's always a factor of 1 that you can put times the top or times the bottom. So I end up with a negative n is the simplification of that fraction. But I know it's very tough to see these videos and not be able to ask questions like, stop, wait, mister, what's going on here? You know, you may have to stop and go back and watch 30 seconds again and reprocess the question. We will have times where we can get together and you can ask specific things, but I just thought I'd make these videos so that I could go through the lesson and show examples and talk them through, and then you'd at least have that foundation, that base to go back to as we practice throughout the rest of this year, the math that we're going to be doing. Um, Example 3, just kind of up in the ante a little bit here because you notice you don't have a 6 and a 6 that cancel out very easily. There's a 21 and a 12. So again, going back to your factor tree, if you need to, grab a new colored pencil, right? And take 21 and go, oh, that's 3 times 7, and 3 is doesn't factor, and 7, well, that doesn't factor. So I know those are my factors of 21, right? It's 3 times 7 times there's an A on top. And then 12, again, it factors into 3 times 4. And 3 doesn't factor any further, but you know that 4 is 2 times 2. And so you can take those factors of 12, 3 times 2 times 2, and then you're multiplying by an A squared in the denominator, which makes A times A, right? And so now you're looking at, again, greatest common factor. You down with GCF? Yeah, Jeff. The 3 on top and the 3 on the bottom simplify to 1. Now there's a 7 on top, but is there a factor of 7 in the denominator? No, there's not. The denominator has a factor of 2. As a matter of fact, it's got 2 of them. But are there any factors of 2 on top? There are not. So the 2's and the 7's don't knock each other out, right? Now there's an A on top that will cancel one of the A's in the denominator because A divided by A is the same factor over itself. But here you now have left a 7 in the numerator, and then in the denominator you multiply all those things back, right? So 2 times 2 is 4 times A is 4A, and the A is still in the denominator, right? It's 7 over 4A. So we're reducing fractions, just like you did in grade school, but using variables makes it a little bit more exciting. And one of the other things you may remember that's kind of exciting is when it comes to factoring, the factor tree isn't always the way to go. So when we start getting into these expressions that involve letters and numbers, we have 2 kind of big types of factorings that we've done this year before. The kind where we bring out that common factor, right? So that would be like an example 4. And then example 5 where you have the trinomial and you factor with the 2 sets of parentheses. Box and whisker method, or the box and diamond method, if you remember doing that from years ago. But here, looking at each one of these examples one at a time. Example 4, you have 9n plus 54, and you have to think about the factors they both have in common. And you want to out. Remember, we can with the 9, because 9 goes into 54, right? We can factor it out. 9 is a factor of 54. So I can bring the common factor 9 out, and that leaves me with, from the first term, an n, because 9n divided by the 9 leaves you an n, right? And what's left over from 54? What number times 9 gives you 54? What's 54 divided by 9? That gives you 6. And that's one type of factoring where we bring out the common factor that these 2 terms both have, right? 9n is 9 times n. 54 is 9 times 6. So I'm going to bring out the 9's from both terms, and that leaves you then with n plus 6 left over. Now in the denominator, there's a 6n plus 36. And 6 would be the common factor there, right? And that leaves you, when you the 6 out, right? An n is left over in the first spot because 6 times n is 6n. And then what's 36 divided by 6? Well, that gives you this other 6, right? So you can always distribute back your number. 6 times n is 6n, and 6 times 6 is 36, and make sure it works. But at this point now, we have common factors, right? There are common factors that cancel, just like up above with the 3's and the A's. We can cancel out this n plus 6 and this n plus 6. They are the same factor. Different kind of factor, right? They're not just numbers or the letter plus a number, but if you let n be any number, like 12 plus 6 is 18, divided by 18 would cancel out. So no matter what number n is, they are the same factor. Now at this point, you might think, oh, my answer is 9, 6. But is it 9/6 is my final answer, 9/6. Oh, not exactly, because 9 is 3 times 3, right? 6 is 3 times 2. So we can keep on reducing this fraction, right? You want to reduce it as far as you can and get it in its simplified form. So 3/2 would be the final answer on number 4. The whole time, this big fraction up here was really just a scary way to say 3/2. Okay. And we're getting it back to its original kind of like most simplified version of itself. Example 5, different kind of factoring here, where you have on top, we're like unfoiling. You have x squared, which is x times x, right? But now we have to think of two numbers that multiply to -4. So -4 could be like 1 times -4, or it could be -1 times +4, or it could be 2 and -2. Any of those three options, they do multiply to -4. But of those three options, notice only one of them adds to the 3 in the middle. So you're thinking of the two numbers that multiply the last number, add to the middle number. And that would be -1 and 4. It has to be -1 and +4, right? So our factors then end up, let me get rid of all these circles because I got to undo them, being +4 minus 1. And if you check that by FOIL, right, x times x makes x squared. X times -1 is -x, but 4 times x is +4x, and -x plus 4x makes 3x, which is our number in the middle. And then 4 times -1 makes -4. So it does factor into x plus 4 and x minus 1. Then the denominator, a little bit easier. Kind of wish we started with this one, because you want them to multiply to 5. So can you think of two numbers that multiply to 5? Well, 5 being prime means that the answer has to be 5 and 1. And in the first spot, you have to have the x and the x, because what's x times x? That's where you get the x squared. Now, the 5 times 1 does make +5, but notice we want the middle term to be -6. So they both got to be negative. X minus 5, x minus 1. Add to -6, but they multiply to +5. And then you see you have the common factor, right? The x minus 1 cancel, x minus 1 cancel. And so the final answer on number 5 is x plus 4 over x minus 5. And that's kind of different because example 4 didn't have any letters left over. All the letters went away. And notice on 5 we have letters, and that's cool. Like those are the factors that remain, the factors that don't cancel out because they're not common, right? So it's all about GCF, greatest common factor. So as I move into my last two examples, what you may need to do is rewind this like 20 seconds and then pause the video so that you can kind of take in everything that's happened. Maybe look at your notes and make sure you're doing them right. I'm going to do the same thing here with these next two examples. Give you a little time to work on them and see if you can do it on your own. Because these videos that I'm making can only be 15 minutes long. So I know you're excited about that. Like, yes, he can't talk more than 15 minutes this time. So for 6 and 7, I want you to factor them both and then cancel out the like factors and then check your answers. So at this point, pause the video. Okay, pause it. Pause it now. Right now, pause it. Pause it now. And whammy, here are the answers. So if you didn't pause the video, go back and pause it because now you're going to be cheating. And why would you want to cheat on yourself? That's gross. Don't cheat on yourself. I'm going to be honest and true and kind. So on 6, again, the numerator, you can like out the 6. 6 is the greatest common factor. The denominator, what two numbers multiply to 27 but add to 12? So that's 9 and 3. 9 plus 3 is 12. 9 times 3. So the k plus 3's cancel, and you have 6 over k plus 9. On number 7, they factor with the 2 parentheses, and the k plus 5's cancel, and you have k minus 10. So here's our first lesson back from spring break, NTI, spring 2020, class of 2020. What I will also now do is put up a PDF with some questions for you to try on your own and then submit back to me for credit. So you can watch this video as many times as you need. And if you need to email me, you can do that too. It's been good talking to you. I'm done. Peace.